So now we'll have a look at the types of miniature circuit breakers. Now we do have 6 classes: A, B, C, D, K and Z. These depend upon the current they carry. Normally we do employ this BCD in our domestic applications, but let's have a quick look about the different types. A type MCB, it can trip the currents 2 to 3 times the actual rating. So it trips off the circuit when your current exceeds 2 of your rated currents. Okay, so it is very highly sensitive to the short circuits, so used in the manufacturing of semiconductors. Whereas a B type MCB, it can withstand up to 3 to 5 times of your rated current, and if it is beyond that, it will trip off the circuits. And it is used in cable protection. The next level is a C, which can withstand up to 5 to 10 times. It is used in electrical appliances, particularly transformers, fluorescent lighting circuits, personal computers, printers, etc. So for all these things, you will be using C-type MCB. And the D-type MCB, it is used when your current exceeds 10 times the rated current. So normally in motors, you will be having a starting current which is generally varying from 4 to 5 times of the normal current. So during that time, I told you MCB should not operate. It should operate only when there is a very high amount of current. 4 to 5 times is also normal, means we should act when it is more than 4 to 5 times. In that case, D-type MCB comes into picture. It will operate when your current is 10 to 20 times of the normal rated currents. So that's why it is used in motors. And intermediate one, we do use K-type one, which is generally used for 8 to 12 times. 8 to 12 times of rated current, then automatically it will trip off. So for compressors, part of the motors and extreme machines, we will be using K-type, which is a little bit advanced one. Now, when you try to compare and fuse and MCB, both are used for circuit protection. So there is a significant difference between the operation and characteristics of a fuse and MCB. So let's have a quick comparison between fuse and MCB. The first one is operation. As already I said, fuses are just like thin wires or metal strips, which usually melt when there is a high current. So when there is an overcurrent, when there is a fault, so the current which is passing through the fuse, it increases. It causes the fuse material to burn, and we call it as a blowing off of the fuse. Whereas in an MCB, if you carefully see, we can use a combination of thermal or magnetic strip mechanisms to detect a fault and respond to overloads. Both are quite different. Coming to resetting, fuses are one-time use devices. Once it is melted off, you should replace it defaultly. You should replace it with a new fuse with appropriate rating. Whereas MCBs, on the other hand, they can be easily reset after tripping. Once a fault is reset, the MCB can be manually switched on, restoring the circuits. And reusability. As mentioned, fuse once used, it cannot be reused. It is to be replaced. So that's why if you do have that problem again and again, then don't try to use fuse in that case. Better go with an MCB if you have an opportunity or if there is a possibility of frequent tripping. Okay. Sensitivity and selectivity. In this case, fuses score a good mark because fuses are very sensitive to overcurrent conditions when compared to MCBs. They can very quickly interrupt the higher magnitudes of currents. That's why they offer more sensitivity. On the other hand, coming to selectivity, MCBs offer more selectivity. They can be very precise in isolating or disconnecting only the faulty circuits. Particularly when you are operating with motors, MCBs are more preferred nowadays. So when you have larger electrical installations, we go with the MCBs now. The next one is a cost. As usual, costs. Fuses do consist of a small, thin, conducting material, right? So that's why they are comparatively very cheaper when compared to your MCB for low current ratings. But if you want to go for higher current ratings, MCBs is the best choice. Okay, because they can offer you long-term cost savings. The next is application orientation. In older electrical installations, industrial applications, and in some specialized equipment, we still are using fuses, but I think they will be phased out in the upcoming years. We are using now MCBs in residential, commercial, and industrial applications nowadays. because they can be reused and they have better protection features, and you can have adjustable time characteristics. So that's why MCBs may replace the fuses in the coming future. And coming to safety point of view, both offer protection for us against overloads and short circuits. But MCBs offer better safety features because we have the ability to manually turn off and turn on. They can act as a switches just like that. So, and even in MCBs, I am not going into deep into the MCBs. There are so many MCBs which have come into picture, just like your molded case circuit breakers, and we do have residential current circuit breakers, RCCBs. These do offer varying levels of protection and capabilities for different applications. They are very reliable nowadays, and the selectivity and sensitivity both are becoming good nowadays. So you can choose MCBs over the fuses. So based upon your budget consideration, based upon the electrical system which you do have, and based upon the safety considerations, you can choose between a fuse or a circuit breaker. The choice is yours. And in the MCBs also, it depends upon your current rating and your application. Okay. So with this, I am closing this session. So I hope that now you are able to describe the need for MCBs, how do they operate, and what are the types of MCBs, and the applications which is used where. Okay. So this is your question. What is the principle of operation of MCB? Can we replace fuse with MCB? What are the advantages and limitations of MCB when compared to the fuse? So which of these two has a quicker response? I think I have told you. Just go back to the previous slides and get that. Or else, compare the performance of fuse and miniature circuit breaker based upon the full line parameters. Okay. And one more thing is trying to get a picture of the fuses or circuit breakers at home, and we'll discuss it itself. Okay. Ensure that some current rating is marked upon that. So take a closer shot of the picture. Okay. Thank you.